Hello everyone, you are watching the Space Channel. Today, we are concluding our 4-video cycle devoted to the most widespread myths about black holes. As always, you can find the links to the previous 3 parts below the video. Check them out, they are interesting. Well, let us continue. Myth 14 can be formulated like this. The event horizons of black holes bend when 2 black holes approach each other because of a compensation of gravitational forces in the region between them, approximately the way you see it on the screen right now. It turns out that the event horizon supposedly collapses inward into the black hole. I cannot even imagine how anyone came up with this, but I have been asked such questions repeatedly. In fact, it is an attempt to describe black holes within the bounds of classical physics, which is inadmissible in this case. Between black holes that are approaching one another, there really is a region where the gravitational pulls toward both holes are equal. Throughout the space between the black holes, the resultant of the forces applied to a body really will be less than the gravitational force toward each black hole separately. An object moving in this region really will deviate less from uniform straight-line motion from the point of view of an outside observer. However, the event horizon of a black hole is determined not by gravitational force, but by the curvature of spacetime, and that is not a vector quantity. The curvature from 2 objects does not compensate for one another, but on the contrary, increases the curvature of space at a given point. Since at the event horizon, the curvature of spacetime becomes enormous. Outside the black hole, given the finiteness of the curvature of space produced by various bodies, it is impossible to obtain the same conditions as at the horizon. Therefore, the event horizon is not capable of bending either inward into the black hole or stretching outward. Myth 15 asserts that all the space beneath the event horizon is filled with matter of enormous density. As we said in the previous myth, beneath the event horizon lies a region with substantial curvature, and its volume is quite large. At the same time, all the mass of the black hole is concentrated in the singularity. In fact, beyond the event horizon, there is empty space, yet physicists still use the concept of density for a black hole. It is introduced as the mass of the hole divided by the volume that encloses its event horizon from the point of view of an outside observer. The density calculated this way decreases rapidly with increasing black hole size, and, for supermassive black holes, becomes millions of times lower than the density of air. At the same time, at the singularity, the density really does become extraordinarily large, but only there. Myth number 16. The accretion disk is visible only if the black hole is turned sideways toward us. If in a photo of a black hole we saw its accretion disk, then we were fortunate that it happened to be turned sideways toward us. If we look at the photograph of a black hole we discussed in detail in a previous part, or at any visualization of a black hole, we will see a dark region in the middle surrounded by a bright ring. And in some visualizations, the black hole is also girded by another ring that passes through the middle of the dark region. The ring around the event horizon is, in principle, the accretion disk, but its location is an optical illusion. A black hole warps the space around itself so intensely that the light from the accretion disk does not travel to us in a straight line. It is refracted extraordinarily strongly in the gravitational well of the black hole, and, as a result, regardless of which side we look at the hole from, we will see the light from its accretion disk. This will happen even if the disk itself is parallel to our line of sight. In fact, this is the very case when another ring passes through the middle of the dark region. And if the disk is perpendicular to the line of sight, we can observe it without refraction. According to the 17th myth, black holes do not move through space but remain fixed at the sites of their formation. This myth is uncommon, but some people perceive black holes as static objects anchored to specific locations in space. In reality, this is not so. Black holes obey the very same laws of orbital mechanics as other astronomical bodies. They also move through space together with galaxies, revolve around the galactic center, and, when colliding with a star, begin to revolve around a common center of mass with it. The 18th myth concerns supermassive black holes and can be formulated as follows. Supermassive black holes in the centers of galaxies are the primary gravitational force holding the galaxy together. This myth, at first glance, really does seem logical. Scientists do indeed state that at the centers of all elliptical and spiral galaxies there are supermassive black holes, whose masses range from tens of millions to hundreds of billions of solar masses. Because these black holes are located at the centers of galaxies, have enormous mass, and exert a significant gravitational pull, people get the mistaken impression that the entire galaxy revolves around them. That is, a hole appeared, it pulled matter toward itself, spun it around itself, and formed a galaxy, and its gravity is decisive in the galaxy, so everything revolves around the black hole. However, this is not the case. The total mass of the stars in galaxies, according to various estimates, exceeds the mass of the supermassive black hole in their centers by hundreds of thousands or even millions of times. For example, the mass of Sagittarius A, the black hole in the core of our galaxy, is approximately 300,000 times less than the total mass of the stars in the galaxy, based on the lowest estimate of the number of stars. Still, the stars are far from all the galactic matter. In fact, the masses of these black holes turn out to be comparable to the total mass of the stars only in the galactic core. Thus, the gravity of black holes turns out to be relatively small compared with the total gravity of the matter in the galaxy. Therefore, a galaxy is held together by the cumulative gravitational force of all the objects that belong to it, and the contribution of the supermassive black hole to it, as we have already said, is insignificant. At the same time, even the black hole itself is actually not located at the galaxy's center of mass. Just like all the other objects, it revolves around the galaxy's center of mass, albeit at a minimal distance from it, which is precisely why the black hole gained such a large mass. Myth 19. Nothing can actually fall into a black hole because it stops at the event horizon. Matter supposedly remains there forever. This myth is actually not entirely a myth. It arises from the fact that most people do not quite understand how the theory of relativity works, and it says that, for different observers, this process will look different. The thing is that as one approaches the event horizon, for an object that is falling into the hole, time slows down, but from the point of view of an outside observer. From that observer's point of view, at the moment the event horizon is crossed, time should stop altogether. Accordingly, the object should not move any farther and will hang forever at the event horizon. But from the point of view of the falling body itself, it quite calmly crosses the event horizon and flies on without even noticing it. It really does seem strange, but that is how relativity works. The last myth in our series is number 20 and concerns not exactly black holes, but rather space as a whole. It can be formulated as a question that I've been asked more than once. Why has no one sent a probe into a black hole to study it up close? This myth is common among people who lack a sense of cosmic scales. The nearest potential black hole to us is located approximately 1,000 light-years from Earth, and the nearest hole into which, in principle, a probe could pass without being torn apart by tidal forces is somewhere between 23,000 and 30,000 light-years from us. Given the level of modern technology, humanity has been able to send probes only to the outer reaches of our system. The Voyager 1 and Voyager 2 probes have so far flown less than one light day, and to exit the solar system, they will need several thousand years. Therefore, we simply do not have the tools to send anything to a black hole. That's all for now. If you liked the video, hit like and subscribe to the channel. See you next time.